How do you find the inverse of a 3 by 3 matrix? Well, the formula for finding the inverse of any matrix is always the same, regardless of the order of the matrix. So the inverse of a matrix is always equals to the adjoint of the matrix divided by the determinant. So the inverse of any matrix, either a 2 by 2 or a 3 by 3, is adjoint over determinant. All right, let's solve a question very quickly so you can get more understanding. So looking at this beautiful matrix, we're told to find the inverse of matrix A. So the inverse of matrix A will obviously be the adjoint of matrix A over the determinant of matrix A. So we can go on to first find the determinant of matrix A very quickly. And the difference between that of a 2 by 2 and a 3 by 3 is in finding the adjoint and the determinant. Of course, you can check out our previous videos to know how to find the adjoint and determinant of a 2 by 2 and of a 3 by 3 matrix. They are quite different from each other. So let me try and find the determinant of this 3 by 3 matrix. What do I have to do first? Well, I go on to place plus, minus, plus. I'm trying to find the determinant. So to find the determinant, what I will do is to take plus with the first element, that will be plus 1. Then I open up these braces. Then I go on to have minus 1, the next one. Then I open up these braces. Then I go on to have plus 1. Then I open up the braces. So to fill in the elements in these braces, which these are determinant braces, you will go on to lock off. This is row 1 column 1. I will lock off the entirety of row 1 and the entirety of column 1. I will left with minus 1, 3, 2, minus 3. Of course, as I said earlier, if you want to find out how to do this, you can go and check a video that dwelt more on determinant of a 3 by 3 matrix. So I go on for this next minus 1. This is on row 1 column 2. So I shut off the whole row 1. I shut off the whole column 2. I'm left with 2, 3, 1, minus 3. Then for the last one, plus 1, I shut off the entirety of column 3 and that of row 1, because that's where we have the plus 1 staying on. Row 1 column 3 is where you have plus 1 on. So you lock off everything. You're left with 2 minus 1, 1, 2. So I'm left with 2 minus 1, 1, 2. So this is what we have to resolve to get the determinant of our matrix. So we can go on to have plus 1. Then the determinant here, this is minus 3 times 1. That's 3. Minus 2 times 3. That's 6. Minus 1. 2 times minus 3. That's minus 6. Minus 1 times 3. 3. Then we have 2 times 2. 4. Minus 1 times minus 1. That's minus 1. So we're left with plus 1, minus 3, minus 1, minus 9, plus 1, 4 plus, minus times minus is plus, that's 4 plus 1, that's 5. So we can have here, we can have plus 1 times minus 3, that's minus 3, minus 1 times minus 9, that's plus 9, plus 1 times 5, that's 5. Now, what does this give us? This gives us a value of 11. So we can conclude that the determinant of A is 11. So we have been able to resolve the determinant of A as 11. So we then go on to find the adjoint of A. So the determinant of A is given as 11. So we are left with finding the adjoint of A. The adjoint of A is always given as the transpose of the cofactor. So the adjoint of A is always the transpose of the cofactor matrix. So we have to go on to find our cofactor matrix. Then we go on to transpose it. So we have different elements here in the cofactor matrix we want to fill. So we have, since this is a 3 by 3 matrix, our cofactor will also be a 3 by 3 matrix. So we want to go on to fill this value. This is C11, C12, and C13, and so on, C21, C22, C23, C31, C32, C33. All I'm doing there is just putting a name to them using their rows and columns. So when I say C11, I'm referring to row 1, column 1. When I say C22, that means this is row 2, column 2. So I want to go on to find the elements of this cofactor matrix. So the first thing I told you to do there is to go on to put in a sign on every element in the main matrix. And you do that by starting with a plus sign, a negative sign, a plus sign, a negative sign, a plus sign, a negative sign, a plus sign, negative, then plus. Now, the only use of this will be at the initial point. You don't use this when solving a matrix. So let's see how we use this. So for our first element, C11, this is where we use this sign. We will have plus. Then this time, don't forget, you are not taking any element. You're just writing the sign alone. Then you are opening up a determinant braces. So for C2, for C12, of course, the sign there is minus. This is where you use the sign. And you don't take any element. You don't take one or any element. You just use the sign alone. So you'll be putting in your resultant matrix, which we'll be solving next inside here. So then C13 will be, here we have a positive sign, and we go on to draw our determinant braces. So how do we fill in the matrix inside here? What we have to do is, since this is C11, this is row 1, column 1, we will block off the entirety of row 1, block off the entirety of column 1. So we'll be left with minus 1, 3, 2, minus 3. Minus 1, again, if you are finding this hard to follow through, I would advise you go to our video that specified majorly on the adjoint of a 3 by 3 matrix. So the C12 here, this is row 1, column 2, you would block off the entirety of row 1 and the entirety of column 2. So we'll be left with 2, 3, 1, minus 3. So for C13, you can guess, you can try and follow through on it. We're blocking off row 1, blocking off column 3. So what was your result? We have 2 minus 1, 1, 2. All right, so you go on to resolve this. This will be plus. Then you find the determinant. Because this is a determinant braces, we put it in. This will be minus 1 times minus 3. That'll be 3 minus 3 times 2, 6. So we have plus minus 3. Plus minus 3. And that will be minus 3. So that's the very first element of our cofactor matrix. So we can fix that here already. This will be minus 3. So to find the other element, you do the same thing. You go on to resolve this. This will be minus. Then we have 2 times minus 3. That will be minus 6 minus 1 times 3, 3. This will be minus 9. Minus times minus, positive 9. So that's the second value for our cofactor matrix. We have 9. And then the third value there, C13, we go on to do the same. 2 times 2, that will be 4 minus 1 times minus 1, minus 1. This will be plus 4 plus 1, 5. So our value there, we have a value of 5. So we can go on to fix that as our C13. That will be 5. So we can go on to find for C21 here. C21 will be, this is minus, minus. So to put in our value for C21, this is row 2, column 1 that we are locking up. Row 2, column 1. So we're left with 1, 1, 2, minus 3. So we go on to find the determinant there. 1 times minus 3, that will be minus 3 minus 2 times 1, that will be 2. This will be minus, then minus 5. This will give us a value of positive 5. We have a value of positive 5 right here. And that gives us the value we're looking for C21. So go on to fill in all the values for our cofactor matrix. So we can go on to find for C22. This will be plus because we have, this is C22 and the sign we have there is plus. So we have plus and we open up our determinant braces. Then C23, here we have minus. Then we open up our determinant braces. Then C31, we have plus. Then we open up our determinant braces. Then let's do for C32, that will be minus, and we open up our determinant braces. So we need to go on to fill in the values for the matrix, the resultant matrix. This is 2, 2. This is row 2, column 2. We short off row 2, we short off column 2. We are left with 1, 1, 1, 1, 1, minus 3. If we short off row 2, column 3, row 2, column 3, we'll be left with 1, 1, 1, 2. Don't forget, you don't use this signs. The signs written in red ink is only for this reason. We don't use it inside here. We don't use it inside here. So for C31, this is C31. We short off column 1. We short off row 3. So we're left with 1, 1, minus 1, 3. Again, for more details on this, I would advise you go watch the video on adjoint of a 3 by 3 matrix. Now, the next one we have C32, C32. So we are left with 1, 1, 2, 3. So we can go on to resolve this. We have plus 1 times minus 3, that will be minus 3 minus 1. That will be plus minus 4. This will give me minus 4 as my result. Then we have minus 1 times 2, that's 2 minus 1. That will be minus 1. Our value will be minus 1. Then this will be plus 1 times 3, that will be 3 minus 1. Minus 1 times 1 will be minus 1. So we're left with plus, this is 4. And then we have minus 1 times 3, that will be 3 minus 2. This will be minus 1. So we can go on to fill in the values for our cofactor matrix. We have minus 4, we have minus 1, we have plus 4, we have minus 1. Let's go on to do the last value here. That will be C33. So C33, we have plus sign there. That will be plus. Then we'll bring out our determinant braces. We're locking up row 3, column 3. So we're left with 1, 1, 2, minus 1. This will be plus 1 times minus 1. That will be minus 1 minus 2 times 1. That will be 2. This will be plus minus 3. Plus times minus, that's minus. So we have a value of minus 3 as the last element there. So we've been able to find our cofactor matrix. So what we have to do next is to find the adjoint, which is the transpose of the cofactor matrix. So the adjoint of matrix A, the adjoint of matrix A is equals to the cofactors transpose. So we have to transpose this matrix, which, as I've said earlier in previous videos, to transpose a matrix, all you have to do is to change the rows to become columns. So wherever you have row 1, you change it to column 1. So this is minus 3, 9, and 5. And then this is 5, minus 4, and minus 1. And this is 4, minus 1, and minus 3. So this gives me the adjoint of matrix A. So we've been successful in finding both the adjoint of A and the determinant of A. So to find the inverse of this matrix, all you have to do is to bring up the adjoint and divide through with the determinant. So that will be what you have right here. Inverse will be adjoint. This is the adjoint over the determinant, which we got earlier as 11. So what you have to do as your final answer is to go on to divide individual elements of the adjoint matrix by the determinant. So we have minus 3 over 11. We have 5 over 11. We have 4 over 11. We have 9 over 11. We have minus 4 over 11. We have minus 1 over 11. We have 5 over 11. We have minus 1 over 11. And we have minus 3 over 11. And this way we have successfully gotten the value for our inverse of matrix A. So this is how simple it is. You just have to follow the procedure. Once you follow this procedure step by step, you can't get a wrong answer. So I'd like you to attempt this question. You have to find the inverse of matrix A, which is given as shown above. So go on to resolve the matrix inverse of A, and I would love you to drop your response in the comment section. If you have any question you would like me to resolve, you can ask in the comment section also. All right, guys, thank you for joining us. I hope to see you in the next video. Bye-bye.